We get to orbit Mercury when we imagine life on other planets. We have to imagine that the environment on those planets will determine what the creatures may look like. There are big secrets hidden on a small planet close to the Sun, Mercury. Though small and hot, Mercury misled us for many years. But now, robots in space have found some strange things, including what they believe to be diamonds on this hottest world, and that's only the beginning. The inside of Mercury is unexpectedly large and unusual. How is it different from other planets? What other secrets does Mercury hide? Astronomers and space enthusiasts have always been fascinated by Mercury, the smallest planet in our solar system. For hundreds of years, its mysterious landscape remained hidden from view, and its secrets only began to emerge when space research made big strides in 1973. NASA's Mariner 10 mission initiated the search for answers about Mercury's mysterious surface. In 2004, the Messenger probe continued this exploration. Our first close look at Mercury came from Mariner 10, the first spacecraft to visit it, capturing images of a landscape filled with craters and strange lines resembling our moons. This mission revealed Mercury's rugged, cratered surface and also discovered that Mercury had a surprisingly strong magnetic field and a larger core than anticipated. These findings challenged scientists' previous ideas about Mercury's composition. The Messenger mission, which stands for Mercury Surface, Space Environment, Geochemistry, and Ranging, began 31 years after Mariner 10, significantly advancing our knowledge of Mercury. Unlike its predecessor, Messenger was designed to enter Mercury's orbit, enabling scientists to study the planet in greater detail. During its mission, Messenger captured an astonishing 200,000 images, revealing previously unseen parts of Mercury. One of its most intriguing findings was that Mercury's darker side contains unusually high amounts of calcium and magnesium, prompting questions about the processes that could cause such concentrations. Messenger also detected that Mercury's magnetic field was unusually strong in the northern hemisphere, which set it apart from other planets. These findings led scientists to realize that Mercury's structure and formation process differed substantially from their initial assumptions. Unlike on Earth and most other planets, where magnetic fields are generated by the movement of liquid iron in the core, Mercury's magnetic behavior is unique due to its distinct core structure. Mercury's surface, apart from having craters and lines, is also extremely warm. Temperatures on Mercury can reach up to 486 degrees Celsius during the day, hot enough to melt lead, and then drop to minus 292 degrees Celsius at night. These extreme temperature variations are due to Mercury's thin atmosphere, which does little to stabilize or retain heat. Despite its harsh conditions, recent studies have uncovered interesting aspects of Mercury's surface. In 2012, Messenger data indicated volcanic activity, including pyroclastic deposits from explosive eruptions, challenging the previous belief that Mercury was geologically inactive. In a surprising 2020 finding, scientists discovered water ice in Mercury's polar craters, shielded from sunlight and cold enough to preserve ice, despite the planet's proximity to the Sun. This discovery raises questions about the potential for simple life forms on Mercury. Could extremophiles, organisms that thrive in extreme conditions on Earth, survive in these icy regions? BepiColombo, a recent mission launched in 2018 by the European Space Agency (ESA), and the Japan Aerospace Exploration Agency (JAXA), is expected to arrive at Mercury in 2025. This mission aims to provide detailed information about Mercury's surface, including its chemical composition and geological history. Mercury continues to amaze us with its features, from a stronger-than-expected magnetic field to water ice near its poles. But there's something even more surprising about Mercury: its day lasts longer than its year. While we typically envision planets revolving around the Sun annually and rotating on their axes daily, Mercury defies this norm in an intriguing way. A year on Mercury, or one orbit around the Sun, takes just 88 Earth days, while a day, one full rotation on its axis, takes 176 Earth days. This unique situation creates peculiar effects. If you stood on Mercury, you'd observe the Sun rise, then reverse course in the sky before continuing its path. This unusual motion results from Mercury's rotation lagging behind its rapid orbit. Why does Mercury spin so slowly? Scientists attribute it to tidal locking, where Earth's rotation has slowed over billions of years due to the Sun's gravitational pull. However, unlike the tidally locked Moon, Mercury follows a 3:2 spin-orbit resonance, meaning it completes 3 rotations for every 2 orbits around the Sun. This unusual cycle impacts Mercury's surface temperature, creating some of the most extreme fluctuations in the solar system. While one side of Mercury endures months of intense heat, the other side remains freezing for just as long. Mercury's thin atmosphere or exosphere also plays a unique role. Constantly replenished by solar winds, nuclear decay and micrometeorite impacts, this exosphere continuously loses and gains gases. Recent research using messenger probe data from 2020 showed that Mercury's exosphere contains more water vapor than previously believed, likely formed as hydrogen from the solar wind interacts with oxygen in surface rocks. Another fascinating aspect of Mercury is its magnetic field. Scientists were surprised to find that, despite Mercury's small size and slow spin, it has a global magnetic field. Studies suggest that this field is generated by a special dynamo effect within its liquid metal core, influenced by Mercury's distinct orbit and rotation. Although Mercury's magnetic field is weaker than Earth's, it plays a crucial role in protecting the surface from the harsh solar wind. This magnetic field also gives rise to unique features on the planet's surface, such as hot poles, where the sun appears stationary in the sky, creating the hottest temperatures on Mercury. In contrast, certain areas near Mercury's poles remain in permanent shadow, preserving water ice. Mercury's specific orbit and spin allow these shadowed regions to remain cool even as nearby areas become intensely heated. Reaching Mercury is a challenge for spacecraft, as its swift orbit requires intricate maneuvers, including multiple flybys of Venus and Mercury. The Bepi-Colombo mission, currently en route to Mercury, uses gravitational assists to adjust its speed and trajectory, a journey that began in 2018 and will conclude in 2025 after 9 planetary flybys. Once in orbit, Bepi-Colombo will face the difficult task of balancing exposure to Mercury's intense heat and conserving power during long, cold nights. These challenges underscore Mercury's harsh conditions and highlight its unusual orbit and rotation. New computer models offer insights into Mercury's rotation rate, suggesting that the Sun's gravity, along with impacts from asteroids and comets, slowed Mercury's once faster rotation. This research not only helps us understand Mercury's past but also provides clues about the evolution of other planets. As we learn more about Mercury, new questions arise. How does its core remain partially liquid under such extreme conditions? How does its unique orbit shape the minerals on its surface? Mercury's characteristics continue to challenge our understanding of planetary formation and evolution, inspiring us to refine our theories and explore new possibilities. The mysteries of Mercury, though it's the smallest planet in our solar system, compel scientists to keep investigating. Mercury's massive core, which comprises around 85% of its volume, remains one of its most intriguing secrets. By comparison, Earth's core makes up only about 15% of its volume, a stark difference that underscores Mercury's unusual nature. But why does Mercury's core weigh so much? One idea is that Mercury may have been a much bigger planet in the past, but most of its outer layers were destroyed in a huge clash early in the history of the solar system. Dr. Eric Isag from the University of Arizona came up with this idea, which is also known as the hit-and-run scenario. This idea says that a big planetesimal may have hit Mercury and stripped away a lot of its mantle and crust, leaving behind the iron-rich core we see today. The strange magnetic field of Mercury is another deep secret. Venus and Mars don't have world magnetic fields, but Mercury does. Its magnetic field is about 1% as strong as Earth's. Scientists were surprised by this find by NASA's Messenger mission because they didn't think a small planet that rotates slowly would have a magnetic field. They were led by planetary scientist Dr. Katherine Johnson of the University of British Columbia, who found something even stranger about Mercury's magnetic field. They found that the field is about 20% of Mercury's radius away from the planet's center. This difference could be because Mercury's shell isn't always the same thickness, which changes how heat moves from the planet's center. Things don't end there though. Scientists said in 2020 that they had found sulfur, potassium, and sodium on the surface of Mercury that could change quickly. It was a surprise to find these elements on a world so close to the Sun because they usually evaporate quickly at high temperatures. Dr. Patrick Peplowski from the Johns Hopkins Applied Physics Laboratory thought that these volatile elements may have come to Mercury from comets or asteroids after the planet was already formed. One of the most exciting new things found about Mercury is that it has water ice and craters that are always in shade near its poles. We already talked about Dr. Nancy Chabot, and she also worked on this study. Even though Mercury is close to the Sun, the ice is still there because these craters never get direct sunshine, which keeps the temperatures very low. It gets even more interesting after that. Experts have found organic compounds in the craters along with water ice. What are these dark deposits? They might be made up of complicated carbon-based chemicals like the ones that may have helped make life on Earth possible. Even though Mercury is very harsh, could it hold secrets about how life started in our solar system? Another big secret about Mercury is that it does strange things with its rocks. Scientists thought for a long time that Mercury was a geologically dead world. However, information from the Messenger mission showed signs of volcanic activity that happened not too long ago. Small bright spots on Mercury's surface that look like volcanic vents were found by Dr. David Rowe from the Open University in the UK. These shapes, called hollows, make it look like Mercury may still be active geologically. One of the strangest things about Mercury is its chaotic terrain, which is a large area of jumbled hills and valleys close to the south pole of the planet. The Mariner 10 mission saw this area for the first time in the 1970s. It's about the size of Texas. A scientist at the Smithsonian Institution named Dr. Thomas Waters thinks that this landscape may have been made by big earthquakes caused by the sun's tides as Mercury's orbit changed. New studies have also found some interesting facts about Mercury's makeup. Data from the Messenger mission were used by Dr. Amir Khan from the University of Zurich to look into the layout of Mercury's interior. His team found that Mercury's core probably has a liquid layer on the outside and a solid core inside, just like Earth's, but Mercury's inner core is much bigger than Earth's, which might help explain some of the planet's strange magnetic qualities. These deep secrets about Mercury make us question how planets form and change over time. They make us think that there are still a lot of secrets to be solved in our own galaxy. As we look forward to new missions and findings, we can't help but wonder what else might be hidden below the cratered surface of Mercury. The secret depths of Mercury. Recent findings and ongoing missions are showing that the deepest parts of Mercury are just as mysterious as the surface. One of the most interesting things about Mercury's deepest parts is how it is put together. Earth's core is solid in the middle and liquid around it, but Mercury's core is mostly liquid with a solid part in the middle. NASA's Messenger mission proved this strange core composition. It used small changes in Mercury's gravitational field to make a map of the planet's interior. It is thought that Mercury's solid inner core is about 1,260 miles, 2,000 kilometers, wide, which is almost half of the planet's total core. This is a lot bigger than Earth's inner core, which only makes up about 20% of the core volume of our world. Its magnetic field is surprisingly strong for such a small planet, but it is much smaller than Earth's. It depends on the size and state of Mercury's core. The mantle below Mercury's rock is not as thick as was thought before. The Earth's core is about 1,800 miles, 2,900 kilometers, thick, but new studies show that Mercury's might only be about 260 miles, 420 kilometers, thick. This thin layer changes how Mercury's rocks move and how heat is distributed. In 2012, Messenger found signs of old volcanic activity on Mercury's surface. This was one of the most exciting things ever found about the planet's interior. Strange shallow depressions called hollows were found by the spaceship. They seem to have formed when volatile elements rose to the surface. These hollows show that Mercury's core used to have more volatile elements than scientists thought. Using data from Messenger, scientists made another important finding about Mercury's surface in 2020. They found signs of a huge underground magma pool that existed a very long time ago on Mercury. This old magma ocean probably had a big impact on how Mercury's surface and insides are formed. Mercury's surface has some interesting features, like the large smooth plains that cover most of its northern hemisphere. This old magma ocean might explain these features. People think that these plains, which are called the northern volcanic plains, were formed by huge lava flows that happened early in Mercury's past. But the most amazing thing found about Mercury's surface may have been in 2022. Scientists looking at Messenger data found proof that nitrogen was stuck below Mercury's surface. This nitrogen could be what's left of an old atmosphere that was pushed underground by the planet's extreme heat and radiation from the sun. The fact that nitrogen is found below the surface of Mercury brings up interesting questions about its history. Could the Earth's atmosphere have been thicker in the past? If so, what might this mean for the temperature in the past and whether or not it could be lived on? Water ice can be found in permanently dark craters near Mercury's poles, which is another interesting thing about its deep interior. This ice is actually on the surface, but you can't see it because it's so cold where it is, and these areas are always in the shade. Some of this ice may be fairly new, having been put there by comets or asteroids in the last few tens of millions of years according to new studies. Along with water ice, these polar craters have dark deposits that experts think might be organic compounds. There is a chance that these substances, which are more volatile than water ice, are left over from comets or asteroids that hit Mercury. These organic materials have been preserved in Mercury's subsurface, which makes it possible to study how organic molecules are spread out in the inner solar system. The past of Mercury's tectonic plates can also be found below the surface. Plate tectonics don't happen on Mercury like they do on Earth, but there is proof that the planet shrunk a lot as it cooled down over time. Many thrust faults have formed because of this shrinkage. These are places where one piece of crust has been pushed up over another. These cracks, which can be several kilometers high, show what Mercury's subsurface is made of and how it formed. A new study of these thrust lines has shown something surprising. Mercury may still be tectonically active right now. As part of a 2019 study, small features known as grabens were found near some of Mercury's biggest faults. These grabens, which are basically small valleys made by the crust spreading out, look like they were formed not long ago, which suggests that Mercury's crust is still moving and settling. The planet's magnetic field is one of the most unknown things about its deep interior. Earth's magnetic field is caused by the movement of molten iron in its upper core. Mercury's magnetic field, on the other hand, is thought to be made by a different process. Some scientists think it might be caused by a dynamo reaction in a thin layer of liquid metal that surrounds a solid core. Another strange thing about Mercury's deep interior is that there may be faults and breaks below the surface that could let heat and maybe even fluids move through the planet's crust. Some experts think that there may be pockets of liquid water deep below Mercury's surface, which is currently very dry. The heat from the planet's core is thought to keep the water liquid. It might seem unlikely that Mercury has water below its surface, but similar things have been seen on other planets in our solar system that don't seem like they would be good places to live, like Europa, Jupiter's moon, and Enceladus, Saturn's moon, both of which have oceans below their icy surfaces. Even though Mercury's environment is very different, it's still possible that there is water below the surface. As we learn more about Mercury's deepest parts, new questions come up. How has the inside of Mercury changed over time? Could there be other acids or chemicals that are volatile trapped below the surface? What might the deepest parts of Mercury's surface tell us about the early past of our solar system and the things that formed the inner planets? These questions show how important it is to keep looking into Mercury. Every new thing we learn about its deepest parts not only helps us understand this amazing world better, but it also tells us important things about how planets form and change over time in the solar system. As we look forward to new missions and findings, one thing is certain. Mercury still has a lot of secrets to tell. Even though it is small and close to the Sun, in its deepest parts, there are clues about its past that could lead to the history of our whole solar system. What a trip, huh? Share your ideas on what you think we might soon find on Mercury. Could it be valuable stones or even life from other planets? Please click the like button and subscribe to the channel if you like the video. That way you'll never miss any new videos. Take care and we'll see you in the next video.